This video is sponsored by PCBWay. In this video I'm going to build gearbox that is powered by 4 775 DC motors. A little spoiler, it will be great. I have done really similar thing before. This is 6 motor gearbox. It's powerful, it works great, but it's too big to use anywhere. That's why the key to my new design is more convenient size and body shape. And I did it well. Also, what makes this model practical is that you can turn this into anything. You can just design your own add-ons and attach those directly to this gearbox. How to do it, I show you in the second part of the video. By the way, this model is completely free for you to download. I always share all my designed models for free. If you don't want to build this by yourself, then just enjoy this video as ordinary project video. But if you do, I show you step by step how to do it. And in this case, you also need those things. In the description, you also find link for those. But now let's get started. For this project we need 4 775 DC motors. Right now I have only 2 and I have no idea when I am going to receive my order. But I borrowed 2 from my 6 motor gearbox. Now I have my motors. Next we need obviously 3D printed parts. I 3D printed everything with PLA and for that I use Grille Sermon D1. First we have to screw all motors to the motor mount using M4x8mm bolts. Actually before that I had to remove a little bit of supports and push 2 bearings to the both sides of the motor mount. When it's done, now I can attach all the motors to the motor mount. It's time for gears. By the way, I say this all the time, but use raft when you are 3D printing gears. If you don't use raft, your gears will have elephant foot and they will not work properly. Here I did a little mistake. There is no need for supports, but I go accidentally leave the supports on and it's just pain to remove now. But the first step with gears, installing square nuts. It's really easy, just hammer those in. If this is done, we can screw set screws through them. Next we can attach all 4 small gears to the motor shafts. Before we can install the big gear, we have to push one 8mm shaft through it. The fit is and have to be really tight, so don't be afraid to use some force. When the gear is at the right place, I secure this to the shaft with the set screws that I previously installed. Now push the shaft through the bearings, little wiggle, and the most difficult part that wasn't really difficult is done. And we can screw the rest of the body parts together. Because I'm doing the video, I'm using a Grille cover. You can 3D print this if you want, but I ordered this from PCBWay, who is also this video's sponsor. By the way, I have used PCBWay service a lot in this channel and all the time they are doing absolutely perfect job. Ordering is so simple. Just upload your 3D model, select the material and you are done. PCBWay have also 3D printing, sheet metal fabrication and injection molding service. If you need some part and you don't have right machines for the job, then it's way more convenient and cheaper to just order needed parts from PCBWay than buying the whole, for example CNC machining, drill bits and so on, to get 1 or 2 acrylic cleats for your project. I'm doing this all the time, so if you need to 3D print or CNC something and you don't have the right machines, PCBWay is your one-stop solution. Actually, before I can continue, I have to glue this bearing holder to the center of the lead. But of course, before that, I already press fit the bearing in there. Again, if you're going to 3D print the lead, you don't need to do this step, because the correct hole for the bearing will be already there. And now finally we can screw those 2 parts to the rest of the gearbox with M4x50mm bolts. This gearbox is now ready to roll, and I forget one small but important thing. A washer between the output gear and this 3D printed part that I just glued to the lead. That's why this shaft has a little bit play right now. But I fix this later because I'm too excited to run this for the very first time. Off camera I wired all the wires to the fuck this sentence. I connected all the motors in parallel to my DC motor speed controller, and the power I will take from the 6 amp LiPo battery. Oh, and one small thing more. Actually it's not so small, but the motor's cover. To make this look a little bit more professional, I 3D printed this type of thing with TPU, and I will glue this to there. Okay, now we are finally done, and this little extra step took me a bit too much time, but let's start with the first test. This gearbox works like a charm. A bit noisy, but not a big deal. And I don't know how I haven't mentioned this yet, but this gearbox have 2:1 gear ratio. By the way, you probably saw this yellow debris inside the gearbox. First of all, in the beginning, the gears will wear in a bit, and it's absolutely normal. Also, I didn't use any lubrication. Of course I should, and I will, but while I'm recording the video, this will be really messy, and it will make the transparent lid dirty and it's not see-through anymore. That's why I didn't use any grease right now. But this video isn't over, not at all. Now I'm going to show you how you can make this gearbox into everything. You can use this gearbox like it is and connect this wherever you want with the coupler, but you also can print add-ons. Here are 2 examples, Planetary Gearbox and Water Pump. Let's start with the Planetary Gearbox. If you have watched my videos before, you have probably seen my yellow Planetary Gearbox, the most popular model that I have ever designed. For a simple reason, it's just so great. Actually, it is working really well. So I didn't design a new one. I took already existing one and changed the outer body shape. And like the last one, this one also is stackable. So you can keep 3D printing those gearboxes and stack them up to the moon. In this case it's not really useful, but theoretically it's possible. By the way, if you are interested about this Planetary Gearbox, I highly recommend watching a video about this. Link down below. So basically I put the planet carrier together, and I also had to change the gear inside the gearbox. For this one I had to use a little bit of supports. Oh, and for this one you don't need to push the shaft through it. You have the option, but it's not needed. This gearbox had 2:1 gear ratio. Now with this add-on it has 6:1. And with the next one 18:1, and so on. And like we see, it works absolutely perfectly. I also designed one water pump in less than 10 minutes. I already know this one will be trash, but I just wanted to prove the concept. But my water pump design is so trash that it didn't even work. For the last part of the video, I want to show you how you can make your own add-ons. First, download the model called add-on for 4x775 DC motor. Of course the link is down below and it's completely free. Then go to your preferred CAD software. I'm using Fusion 360. Import the model that you just downloaded and you can start working. I uploaded this model as step file, so it's really easy to work with and all CAD software support it. By the way, if you are going to design something cool, also upload the models to the tanks, and if I see a lot of cool designs, I will print, build and make video out of those. And big thank you to everyone who is still watching this video. I really hope you enjoyed. Also huge thank you to everyone who have subscribed to my channel. I am so close to 100,000 subscribers. 2 years ago when I started this channel, I didn't even dream about those numbers. So if you are not this channel subscriber yet, I hope you will, because I have a lot of stuff coming up. So again, thank you for watching, thank you for subscribing, thank you for everything. See you guys in the next video. Bye.